Steel is the backbone of modern civilization. Every skyscraper, bridge, vehicle, and industrial machine relies on steel for strength, durability, and resilience. But have you ever wondered how raw iron ore transforms into the versatile steel that shapes our world? In this documentary, we will explore every stage of steel production in a modern, fully automated factory, showing the precision, technology, and craftsmanship that go into producing steel at industrial scale. Raw material preparation. The journey begins with raw materials: iron ore, coal, limestone, and recycled scrap metal. These materials are carefully sourced and transported to the factory. Iron ore is crushed into smaller pieces, coal is converted into coke through a heating process, and limestone is finely ground. Every ingredient is measured precisely to ensure perfect chemical balance. Automated conveyors and sorting systems move the materials efficiently into storage and mixing areas. Blast furnace and smelting. Next, the raw materials are fed into the blast furnace. Inside this enormous furnace, temperatures exceed 2,000 degrees Fahrenheit 1,100 degrees Celsius, melting iron ore while separating impurities. Limestone acts as a flux, removing slag and other unwanted elements. Hot air is injected into the furnace, accelerating chemical reactions. Molten iron collects at the bottom, glowing bright orange under the intense heat. This stage is crucial because it determines the purity and quality of the steel that will follow. Steelmaking. The molten iron is transferred to a basic oxygen furnace, BF, or an electric arc furnace, EF. Here, oxygen is blown into the molten iron, reducing carbon content and refining the material into high-quality steel. At this stage, precise control over temperature and chemical composition is maintained, ensuring the final steel has the desired properties: hardness, flexibility, and resistance to corrosion. Automated monitoring systems constantly measure every parameter. Continuous casting. Once refined, molten steel is poured into continuous casting machines. The liquid metal slowly cools as it flows into molds, forming long slabs, blooms, or billets. Continuous casting ensures uniformity, reduces defects, and produces steel in ready-to-roll shapes. Advanced sensors detect any imperfections during casting, ensuring the highest quality standards. Hot rolling and cold rolling. After casting, the solidified steel slabs are transported to rolling mills. In hot rolling, slabs are passed through high-pressure rollers, reducing thickness and shaping steel into sheets, beams, or rods. Cold rolling is sometimes applied for precise thickness, surface finish, and hardness. Every movement of the steel is monitored by automated systems, detecting cracks, bends, or surface defects. Robotic arms and conveyors maintain perfect alignment and flow, ensuring uniformity throughout production. Finishing and coating. Finished steel may undergo additional treatments: galvanizing, coating, annealing, or pickling. These processes enhance corrosion resistance, durability, and surface quality. Each batch is inspected rigorously in laboratories using advanced instruments that measure tensile strength, hardness, and chemical composition. Only after passing these tests is steel approved for shipping to construction sites and industries worldwide. Packing and distribution. The final steel products are cut, bundled, and prepared for shipment. Massive cranes, conveyor systems, and automated trucks ensure safe handling. Steel is then transported by trucks, trains, or ships to factories, construction projects, and industrial sites around the globe. This entire journey, from raw iron ore to finished steel, demonstrates the combination of human ingenuity, advanced technology, and industrial precision. If you enjoyed this documentary, don't forget to like this video, share it with friends, and subscribe to the channel for more behind-the-scenes factory explorations.